Hello everyone. In today's video, I will be talking about states of matter. So the first question is, what is matter? So matter is anything that occupies space and have mass. The chair on which you are sitting, the pen with which you are writing, your laptop, your table, everything is a matter. And even the juice, the water that you drink is a matter, and helium gas, oxygen gas, carbon dioxide, the whole air that you breathe is also a matter. Because all of these things need some space to put, they occupy some space as well as they have some mass. So we conclude that our whole universe is made up of matter, and matter is composed of some small tiny particles. And later on, we came to know that these particles are basically atoms. There are three states of matter. Matter can exist in the form of solid, liquid, or a gas. So these three states are different from each other on the basis we can just differentiate them on the basis of shape. If we talk about shape, solids have a fixed shape, while liquids have a shape of a container. They do not have their own shape, but they just shape in the shape of container. For example, if there is a juice in a glass and I ask you what is the shape of a juice, of course you are going to say that it is having the same shape as the glass in which it is present. In the similar way, gases also have no definite shape, but they have a shape of the container. For example, oxygen gas will have the same shape as of the cylinder in which it is enclosed. If we talk about fluidity, first of all, I would define what is fluidity. Fluidity is defined as whether it can flow from one container to another. So, of course, solids do not flow. You cannot pour them. A chair cannot. You cannot pour a chair from one container to another. But if we talk about the juice, juice can be easily poured from one glass to another. In the similar way, gases can also be poured or can easily flow from one container to another container. If we talk about a volume in solids, they have a fixed volume. Liquids also have a fixed volume, but gases do not have a fixed volume. They always expand to fill the container. What does this mean? It means that if we talk about a liquid and I say I have a glass that can have 10 ml of water, but I just put 5 ml of water in it, we are going to see that the water will be present in half of the glass. Half of the glass will be empty in such a situation. But if I talk about a gas, there in the cases of gases always expand and they always try to fill the container. In the if I just add 10 in the similar way, if I have a cylinder in which I can put 10 ml, not 10 ml, instead 10 meter cube or centimeter cube of a gas, in which the maximum capacity of a cylinder is 10 meter cube or centimeter cube, and I add 5, of course, you cannot see the gas is present in half of the cylinder. Instead, you are going to see that gas particles are simply going to expand and they are going to fill the container. If I talk about density, solids have high density, liquids have high to moderate, and gases have very low density. If I talk about movement of particles and arrangement of particles in solids, particles are arranged in a closed packing. They have a very close packing, and each particle have a specific position due to which their movement is very restricted and they do not move, only particles vibrate at their specific positions. If I talk about a liquid, liquids do have, they are closely packed, but they do not have a regular arrangement of particles, or their particles are not having a specific position due to which liquids can move around or pass each other. Atom gases, there is no regular positioning of particles, and gas particles are present at a far distance from each other, due to which they have a very random movement. Their movement is so random that these particles collide with one another as well as with the walls of container, and after every collision they change their direction. So what are basically these particles, and what are these particles that you see in brown color? These particles can be atoms, they can be molecules, or they can be ions. If I talk about helium gas that is filled in the balloons, in helium gas, particles are basically helium atom. Such atoms are going to combine to form a helium gas. In the similar way, in water, this is one water molecule. So a large number of water molecule will form water. And in the case of salt, sodium chloride, that is a table salt that you use in your food. In the case of sodium chloride, these ions, oppositely charged ions, positive, negative ions, arrange in specific position to form a salt. So yes, matter is made up of small particles, and these particles can be atom, they can be a molecule, or these particles can be ions. So kinetic particle theory of matter states that these three states, solid, liquid, gas of a matter, are very different from each other due to movement and arrangement of particles in them. And the spaces between these particles is called intermolecular space. So we can say that gases have a large intermolecular space, while liquids have a small intermolecular space. And in gases, these intermolecular spaces are so big that these particles just move in a random direction. While movement, they collide with one another as well as they collide with the walls of the container, changing their direction. At the end, we will be talking about the relationship of volume with temperature and pressure. So first, we are going to see that how the volume is related with the temperature. So volume and temperature have a direct relationship. Direct relationship means that they are directly proportional to each other. By increasing the volume, temperature is increased, and by decreasing the temperature, volume is also decreased. This is a diagram where you can see that we have increased the temperature from T1 to T2, and due to increase in the temperature, particles of a gas have got energetic, they have got more energy, and due to more energy, now they can have more movement, or they are going to expand. So we can say that volume is going to increase. In the similar way, if I talk about volume and pressure, by increasing the pressure, volume is always decreased, and by decreasing the pressure, volume is increased. So we can say that they are inversely proportional to each other. Over here, you can see in a graph that by increasing the pressure, volume is getting decreased. So over here in the diagram, you can see that whenever you, in the first diagram, when they are lowering the pressure, as soon as pressure is decreased, these gas particles are going to move more. They are going to get more space. As a result, these particles are going to expand and volume will be increased. While in this part, you can see as the volume is as the pressure is decreased, I'm really sorry, as the pressure is getting increased, you are putting more pressure, these gas particles are coming closer to each other. As a result, volume is going to increase. So yes, they have an inverse relationship. By decreasing the pressure, volume is getting increased, while another part, by increasing the pressure, volume is getting decreased. That's the end